Yeah, our featured presenter tonight is Jason Bock. Jason Bock is a Microsoft MVP, works at Rocket Mortgage. We've had him come out here multiple times. A fantastic presenter. I'm so excited to have him, and he is going to present on how to level up our C# skills, how to write modern C#. So with that, I'm going to hand it over to Jason. Thank you, Jason.
All right. Let me get my screen shared here and share. Manage windows and all yours. All right. Can you see it?
Yes.
Okay, cool. All right. So thank you for having me. I appreciate it. One thing that I'll say real quick is when I'm doing my presentation and I put it in, when I put PowerPoint in the presentation mode, if you see I keep looking down, it's because I have Teams on a lower screen on my desk. And what's going to happen is the presenter, you'll see the slides. I'm going to see the presenter stuff. And so it's unfortunately going to cover Teams. When I'm doing demos or stuff like that, and I don't have PowerPoint like it is right, like the way it is right now, I can see chat. So the point of why I bring this up is if you have a question, I would I'd really like to hear the question. If you put it in chat, I might not see it right away. It depends on if I got the slides up. So I'm okay if you want to come off of mute if you're remote, or if you're in the facility there. If you have a question, I would be more than happy to answer it, but you might have to get my attention. I might not see it in chat. So that's the only thing I want everybody to be aware of. So with that, I am going to get started. All right, so my talk tonight is called Writing Modern C#. I am a staff software engineer at Rocket Mortgage, and this is a little bit of information about myself. And the next slide, I'll show you a link on where you can get my slide deck, so don't have to try to write all this down, but that's a couple places that you can find out a little bit more about me. As I said, if you have questions during the talk, please feel free to ask them. If something comes up later, that email address at the bottom is the best place to get a hold of me. So feel free to send me a question that way, and I'll try to answer it as best as I can. All right, there we go. So I am going to do a fair amount of demos in this talk, and the repository is at that first link. So you can get the code if you want, you can follow along, whatever you want to do, but that's where the code is for my demo. I keep PDF versions of my slide decks at the second link. So if you want to get the slide deck for this presentation, go there and you should be able to find it. So I'm going to talk a little bit about language evolution and how C# has evolved over the years to where we are today. A lot of the talk, like I said, is going to be in a demo, and that's going to be the second bullet point there. And then I'll end with a call to action. So language evolution. I have been doing this now for quite some time, as I would imagine people in the room. I was talking before when we were making sure everything was set up, that I actually did a talk sometime in the late 90s when this was the Capital Area Visual Basic group, and Hal was there, and I was actually there in person. And that's just around the time, maybe a year before, there was an announcement that there was going to be this whole new .NET thing and a whole new language. So it was just on the cusp of C# actually becoming a publicly known thing. And if you go to Microsoft's website, and so if you get my slide deck, you'll see in the notes section, I have links to things that I might be referring to at that particular slide. This is just copy pasted from Microsoft's site. And so you don't have, you can read this if you want, but if you notice, you'll see the terms object-oriented in there at least a couple of times. And that's true of C# in terms of its roots and where it started from, which the first version was in 2002. So we're on a 23-year-old language. It's older than my kids, which is sometimes hard to imagine, but it has a very long history at this point. And when it started, people even forget that there was this Microsoft Sun lawsuit battle that was going on with Java and Microsoft extending Java with J++. And you mention this to kids these days, and they have absolutely no idea who Sun is or what J++ was and all these things. But that kind of was the catalyst to Microsoft kind of being able to do their own thing. And that's where C# also came from. And so C# itself has been around now for quite some time. And one of the things, and this is also really the reason I wanted to do this talk, is over the years, the cadence and the way features have been introduced into C# has changed substantially. So this is a wonderful, wonderful table that shows you all of the versions that came from C# and what years they were, what month and year they were released and the feature count. Now, that's kind of a useless statistic because one feature may be very, very powerful. Like if you look at version 5, you'll notice that there was only 3 features. One of them was the whole concept of async, await, and task, which was a huge feature. So, the number doesn't have a magnitude or what's the relevance or importance to it, but it's a metric. And so I'm just going to use it to say these are the number of features that were released in each version. But there is something to notice about this cadence, and it's kind of around where I just put that line on the slide. So between version 5 and version 6, something changed. And what that change was something called Rosalind. Okay. So if I go back here, version 1 and beyond, everything underneath the scenes was actually using a compiler that was written in C++ and some C, but it was not written in C#. And if you talk to any of the people on the compiler team that have been there pretty much since .NET started, they'll tell you that the intent is to have C# compile C# right from the get-go. But as we all know, schedules, features, business pressure, all this stuff kicks in, and they just weren't able to do that at that time. But they had always been keeping a version of this managed compiler around ever since the beginning. They just never had the time to actually go back and say, let's make this the underlying compiler for C#. But over the years, they started to slowly but surely, if you remember, they used to have a conference called PDC, and Anders Hallsberg would be up there and he would, talking about the new C# features, and he would sometimes mention this thing called compiler as a service and talking about how things in the compiler may change. And then they announced Project Rosalind, I think around 2009 or 2010, and start talking about the fact that there will be this API that people can use to do this code analysis and refactorings and all these things. And by the time version 6 came around, that's when they finally made the cut to saying now C# is using Rosalind. But another big change with this change was it went from closed source to open source. So before C# 6, everything that was done in .NET was essentially closed source. And for a lot of reasons, they wanted to move away from that model. They wanted to have it be open source. They wanted it to be cross-platform. They didn't want to just target Windows only. And if you think about it now, how good of a decision all of this was, at least in my opinion, I think this was a great decision, because I'd say in the last 5 years, I don't think I've deployed anything to a Windows server in quite a long time. Everything is in the cloud, it's in containers, it's in Kubernetes. Everything has changed. And if Microsoft hadn't made that adjustment, I don't think .NET would have survived, at least as long and as prosperous as it has with this change. So we now have a compiler that's open source, allows us to run our C# code pretty much anywhere where code can run. Well, one of the consequences, and I don't mean that in a negative way per se, but one of, because every action has a consequence, and sometimes those consequences are good, sometimes they're bad. One of the consequences of doing this is things started to ramp up a little bit because now anybody could contribute to the code base. Obviously, Microsoft just doesn't let anybody contribute a feature whenever they want, but there's more community interaction. Lots of people from outside Microsoft have actually done little bug fixes, little improvements here and there to not just the compiler, but to .NET as a whole. There's a lot more effort done than just people within Microsoft's walls. And so what I did is I took that data that I showed you before and I turned it to showing, well, over the years, how many features were put into each version. And again, if you look at that dot, that's when Roslyn became the default compiler. And the thing to notice from the left side and on the right side is that before Roslyn, there was about 52 features in 10 and a half years. And after Roslyn, and this includes C# 13, which came out in November of last year, after Roslyn, 124 9.5 years. And so what that basically roughly comes out to is we're getting almost 3 times as many features per year with C#, with Roslyn in place than what we did before. The whole tempo has changed quite substantially. And being somebody that's been in .NET and C# and Microsoft technologies for pretty much my entire career, which is getting on, I think, yeah, this year it will be 30 years as a software developer out of college. And that's hard to fathom and admit, but that's the truth. So been around that long doing this kind of stuff. And one of the things I noticed is that when .NET came out and C# came out is especially around like 5 or 10 years after C# had been in play, is there was this general feeling of it was moving like a glacier. It wasn't moving fast enough. There are all these, the cool new kids in town are Node and JavaScript and Linux and all these things where people are just evolving things rather rapidly, and there's a lot more community involvement. And Microsoft with C# is just, it felt like it was kind of sputtering at times. It's almost the reverse now. One of the things I actually hear people complain about is that it's moving too fast. They can't keep up. There's so many new features. We get a new release of .NET literally every year now, and I'm feeling overwhelmed. I feel like I can't keep up with the latest and greatest, and it's just kind of leaving me with like scratching my head and feeling confused. How do I do this? And so it's almost like the pendulum swung from being way too slow to being way too fast. Now, I personally, my opinion on this is I love it. I love that that things have sped up and that there's more innovation and there's frankly a lot more stability. There's a lot more opportunity in terms of where you can execute your code and where you can run things. I really enjoy that. I feel like there's a lot more evolution in C# than what it used to be. But I can also appreciate where sometimes people feel like it's not that it isn't stable, but they feel like they're maybe falling behind or that they're not doing the latest and greatest things. And if they don't keep up with this, that they won't be able to use certain features. And to be fair, there are some features that require you to not be on .NET Framework anymore. You have to be on what's considered .NET. That's the 5, 6, 7, 8, and now we have 9. The one that you can use for cross-platform development. So how do you handle this? If you do feel like this is kind of overwhelming, if you do feel like this is becoming too much, how do you keep up? How do you kind of combat that notion? Well, I think it's true that no matter what language you're using, no matter what you're doing, there's always this sense of continual study. We have all these tools and resources that help out so much. I I do have to admit, I sometimes, I know everybody talks about the latest and greatest with AI. I still have a mixed feeling about it. I last night just asked, um, I asked what Copilot. I said, how many calories are in a piece of chocolate cake? And it told me that piece of chocolate cake has, I think, like 360 calories. A piece of chocolate cake with frosting on it has 235 calories. I'm like, that's a life hack I never knew about. You put frosting on a piece of cake and get less calories. Who knew? So, but to be fair, these tools I think are going to be evolving. And I think as long as people always put that validation in play, and just like you do with any input you get, and say, is this actually true? Is this code that Copilot just stuck into Visual Studio or Writer, whatever you're using, is it actually valid? Or am I just taking it at face value? I would do the former, no matter what. You always have to make sure that it is doing the right thing. But it's also true that these things actually do help with some of the rote stuff. I think Scott Hanselman called GitHub Copilot the world's most neediest puppy, and that you're typing and it's literally just trying to put all this text into your code, and it's really, really trying to make you happy and impressed. And sometimes it nails it. Sometimes I'm really impressed with what it does. And then there are other times I'm just like, shut up, go away. You're really bothering me. But we have all these tools. We have all these things that can help educate us. But that's the thing I think we need to always keep in mind with any language that we use is you have to keep yourself educated on it, and you have to spend time using it. I'm a firm believer that whatever language you want to use, you can get up to speed and do the essentials and get the basics, and you can even read code. And no matter what the language is, you can probably, if it's written well, if it's written in an idiomatic sense, like what's considered to be what most people would write in that language, you can probably read it. If you don't know Python, but it's written well, you could probably go up to a piece of code in Python and get the gist of it. Now, you can't do that with Perl. Nobody can do that with Perl, but that's a different beast entirely. So, but it's one thing to read code and kind of understand it, and maybe you can make some edits to it and do some changes. But I think to really master and understand a language, it takes time. Be that months, maybe that's a year or two, but it does take some time, I think, to really grasp a language at its core. And that doesn't change because new things are always coming into play. And where does that work, and how do you want to use that within applications you write? But as I just said, the tools out there now make it much easier to discover these new features, to discover what I can do differently in my code, so that I can actually just make changes without even realizing that I'm using a new feature. And suddenly my code may look more concise, or maybe it's a little bit easier to navigate. Now, also one thing to keep in mind too is C# is, as I'm about to show you, a lot of features that have come into play in general, I think are all about conciseness, are all about making your code that there's less noise in your code. Some people don't like this. Some people, especially when I talk about top level statements, some people don't like that at all and say that's not the way C# is supposed to look. So some of these are just, is it the syntax that you like to see? You don't have to change this. Some of these, though, are completely new features that don't exist in previous versions of the language, and there is no way differently to do it. So keep that in mind, that as you see these tools light up some of these new things, it's also kind of a value judgment. Do I really want my code to look that way or not? Okay. So what I'm going to do is I'm going to get out of slide world, and oh, Rocky agrees with me. Can somebody screenshot that? He usually doesn't say that very often. I've known Rocky for many, many years, and we actually do a workshop together these days, and it's very, very rare that he says he agrees with me. So so I'm going to get into my code here, and yes, you can already see there's red squiggles. We'll get to that in a moment. But one of the things I'm going to show you in this project is, one, there are errors here. Yeah. And that's by design. So if you open this up and you're like, why is this speaker giving me code that has a bunch of errors in it? There's an explanation here, and I'll get to that in just a moment. But one of the things I want to do first is, these days it's not so much it's not all just about your C# code, it's how you set up your projects. And some of the switches that you can turn on that I personally find make it easier to keep your projects and your code more consistent and easier to use. So let me actually go into my solution here. And one of the first files I want to talk about is .editor config. So years ago, there was this kind of sort of pseudo standard that started to come up to say, I want my projects, I want my code to follow the same conventions. And it was pretty simplistic. It only had like about 5 or 6 settings. And they're actually, if you can remember the INI format, the any format for text files, that's what editor config files are. So they look like this. Okay. And so they really only had a couple of simple ones like indent style and things like that. But any language could take this and use this for however they want. So you can see here that C# provides a lot of settings that you can say, I like to use expression body members. We'll talk about that in a moment. I like using var everywhere. So I actually have that set to true. And I also have it set to error. I'll explain that in a moment as well. But the point of this file is you can put this into your repository and you can make it such that this will enforce coding styles and conventions for everybody in a project. I'm a firm believer that a coding style is necessary for a project. And I think people should try to kind of follow the same conventions, even if they're not ones that you personally like. You know, everybody does it the same way, but I don't want to memorize the whole coding standard either. That's kind of useless. So this file helps in terms of saying, hey, we want everybody to use var. So we're going to enforce that into our project. Or maybe you don't. Maybe you want people to put in the type name and make them suffer by actually typing in a bunch of characters with their hands. That's up to you. I have opinions. But if that's what you want to do, you can set these to false. Okay. Now, you can also use with editor config files, you'll see open with, there is a UI version of this file. In fact, I think if I just double click on it, you can see that there's this one that may be a little bit more friendly to use. So you don't have to go into a text file and edit it that way. And you can kind of go around and see like, what do some of these mean and how do I set them and things like that. I personally, I like editing it from a text perspective, but it's really up to you. Either way, you put this at the root of your directory structure, and Visual Studio will honor it for everything that you do. In fact, one thing I always love to say is when I show this file is I use tabs because tabs is right, spaces is wrong. Sorry if I offended somebody. But the point is I can have this set to tabs or spaces, and it doesn't matter how my tool is configured, whether it be Visual Studio or Writer or whatever I'm using. This is the indent style that will be used for the code within this project. And so that's one thing you can use when you're using different features, and is enforcing which ones you want to use or not use or do something different. Okay. Another thing to consider are these two directory files. The first one is called directory.build.props. Okay. And so if I open that up, that kind of looks like settings that you'll have in a modern C# project file, except they're in this directory file. And the reason that I would encourage doing this is because if you put this at the root of your code, all of these settings will be applied to each project within that code, within that directory structure. So in other words, I don't have to say in every project that the target framework is .NET 9. I can do it here, and then all of them will be .NET 9. I want the language version to be the latest. They're all going to be the latest. I want analysis mode to be all. Okay, so all these settings that you typically put in a project file, put in here, and those will cascade down to every project. A project can decide to override them if they want, and that's fine. But this is kind of like the default setting for everything within your solution. So I think that's nice too. A couple of settings here to keep in mind. One of them is nullable enable. This is actually at this point turned on by default. So these are called nullable reference types. But this is something that I would strongly encourage you to start using. I'll show this in my demo as well. But if you haven't used nullable reference types, or you've kind of wondered what the question mark is, that's That's what I'll get into, but that's something you have to turn on to use. At this point, Microsoft has now deemed that because they have all of their APIs annotated with nullable annotations, they think now that everybody else should start to honor that as well, which makes sense. So that's one setting. This other one, implicit usings set to enable. You'll see this when I start to open my code, why this matters and why you don't need to have as many usings in your code anymore. Manage package versions centrally. So I think a lot of people probably use NuGet packages in your code and downloading stuff from NuGet and using certain things to make your writing code a little bit easier. Typically in your CS proj files, well, you saw there was nothing in that one. If I go to my tests, you'll see that I have package references, but I don't have versions listed there. So when you set this manage package version centrally to true, what that tells Visual Studio is that package version information should be found in this other file, directory packages props. And if I open that up, you'll see that I have package version elements with the versions there. So what this does is it keeps all of your NuGet packages in sync, because all of them, like if I reference NUnit in a couple of test projects, they're all going to use this version by default. And so you don't have to do any like, I forget what they call it in NuGet, but where you have to basically like consolidate or resolve all your packages so they're like, you try to keep them all in sync. This does this out of the box for you. So this is something else in a modern project I would highly recommend using, is this. As before with these settings and directory build props, you can go in and change some of these individually. If you want to set the version for a specific project, you can do that if so desired. So again, that can be all overwritten, but I love directory or managing package versions centrally. And yes, Rocky's saying turning it on if you never had nullable on before, which he just experienced the pain with CSLA and getting that all nullable annotated, that can be tough. If you're using a new project, I would highly recommend turning this on. If you have an old project, I would still recommend turning it on because it might find nullable issues in your code, but understand that it may take some time for you to actually go through and refactor all your code to do that. One other thing also that I would highly recommend you set, and this gets back to why I have error as true in my editor config, is this treat warnings as errors. So analysis mode basically means how much code analysis do I want to have done in my project? And I have that set to all. So I have all the analyzers that .NET has out of the box. They're all turned on. But then I also have treat warnings as errors on, because I kind of make the analogy of a stoplight. If you're going to a stoplight and it's yellow, what do? You probably floor it, right? You probably shouldn't, but most people will try to gun it. Or these days, even if it's red, I've seen people just go through anyway, young kids these days. But if you say treat warnings as errors, it takes some of these warnings and actually makes them errors so that it will stop your build. And somebody from the Microsoft compiler team, I loved one of the quotes he said, which is, warnings are errors that lack conviction. And so turning this on to true will make these warnings that are in all likelihood probably helpful, makes them so that you really got to pay attention to them. Okay. So that's another setting I would consider turning on. File by file nullable enable helps. Yes, you can do that too. If you're taking an old project and trying to get nullability enabled, you can do it file by file if you want. But once you get to that point, then I would remove all of them and just say have it enabled by default, especially with new projects. That's the default anyway these days, is to have it enabled. So those are a couple things I just wanted to bring up and stuff to keep, to keep in mind, because you can end up having, like I showed here real quick, you can have a CS project file, a C# project file that literally has nothing in it because it's taking all the defaults that are from this directory build props file. Okay. So that's some of the project stuff that I wanted to go through first. Now I'm going to go into some code here and try to clean up that person class that I have that had all the red squigglies underneath it. So we'll come back to here, and you can see that I also have two markdown files in here because I have a starting point that has all the red, and then you can use the code within this ending point markdown file if you want to see what the end result is that I'm going to be going through as I refactor this through Tools and Visual Studio. And if I screw up my demo, I can always just go to the end and just copy paste that code and show all the new stuff. But let's go back to the person class. Now, the first thing you may notice, and maybe a little bit hard to see on the screen, but one of the things to notice here is that these using statements, they're all grayed out. Now, it's not uncommon sometimes as you're writing code that you may take code out of that file such that you don't need a using statement anymore. And so you can do the control period or the little light bulb thing here. I love using the keyboard because it's so much faster. But if you use control period on a line of code here, that will bring up things that you can do to refactor your code. In this case, it's saying remove unnecessary usings. And I can also do it across a document, project, or solution. So that's nice because these refactorings, I no longer have to do it per file. I could just say remove them across all my files and do that refactoring at once. But this is more than what you might usually run into, especially when you say, well, GUID is part of the system namespace. So why is it saying that that can go? And the reason why, again, is because in directory build props, we're using implicit usings. And so each project SDK, like this one here, this is just the default Microsoft.NET SDK, has a set of implicit usings that are typical with every project that people use. So a lot of times people will use these, so you don't need them anymore. You don't need to define them in it at the top of your code. So you can just say remove them. So that gets rid of probably 6 or 7 lines of code up there. Did that make your code faster? No, doesn't change that at all. But again, that's that concept of less noise in my code. That's a little bit less that I have to deal with. Okay. Now, what's wrong with the namespace here? Well, there's nothing. Namespace is defined with this kind of block syntax, has been in there since day one. So there's nothing wrong with it. But in my editor config file, I've set it that I want to use what's called file scoped namespaces. This is a new feature that came with C# 10. And so what that looks like is if I say, give me the refactoring to convert to file scope namespaces, it will now do this. So you'll notice that the block is gone. And so now I have less indentation off of the left side. Okay. Some people like me love this. I actually really like this. It basically says everything else in the file is in this namespace. So you don't need the blocks there. Some people absolutely hate this and do not want to change your C# code to get rid of this. This, again, doesn't make your code any faster. It's more just about conciseness. So if you want to use this, great. If you don't, that's fine too. I personally like to use this. Okay, so that's another small little feature that I think helps with making your code a little bit. And again, Rocky agrees with me, and this is great. I'm loving this tonight. So a little bit less noise in your code, a little bit less indentation. Okay. What's another thing we can do here? So this is a little subtle. In my constructor here, well, you can see there's like this little squiggle, this little smudge of white dots here. I'll come back to that later on. The thing I want to do in this constructor is use something called a tuple. Now, tuples were added in C# 7, and I'm just going to put in here, if I had a method that wanted to return an int, get data, I don't care what that does, it returns 0. But let's say I wanted a method to return multiple values. So what they added is this concept of a tuple, so I can do this and say, something like that. Okay. So you can use tuples now to return multiple things from a method. But tuples can be used anywhere in C#. And that's the nice thing is when they add features to a language that aren't just for one specific thing, they make them so that you can actually use them in different places. One of the things you can do is in this constructor, really, I could do this in any method, but I'm going to do in the constructor is do this. This dot age is equal to that. Thank you, helper. Okay, so that is exactly the same code that what was just there. Okay, there's no difference in performance, but it's less code. It's a little bit less to have to make sure you're doing. It's all in one statement. Okay, so that's a nice little trick. If you like tuples, you can also use them within methods if you want. You can define tuples wherever you want and then do assignments all in one shot. The other reason why this has red squiggles on it now is because, as I briefly mentioned before with the editor config file, is I like this thing called expression bodied members. This member, this constructor, only has one thing in it. That's it. And so what you can do is, I'll tell it to do the expression bodied member is that. Okay. So this may look like a lambda, this big arrow syntax here. That may look like a lambda, but it isn't. This is basically just saying I don't need a block here. All I'm doing is one thing. And so that's all that this method or property or event or whatever you want to do here, whatever you have as your member, you can just say it's just this one thing here. Okay. Also, I do have to bring this up. I'm going to zoom in real big on this one because I do get this question a lot, which is, what is that symbol? A lot of people will look when I'm writing code, I'm doing presentations, I almost always get a question like this. What is that symbol? What it is it's that. It's the big arrow, except when I put them together, it puts it together like that. This is called a ligature. I'm using Cascadia code. And so Cascadia code as a font will do these kind of nicety things where if I have like not equal to, it does that. So if you're wondering what that was, it's nothing. It's not like a special symbol in Visual Studio or in C#, I should say. It's just the font combining it to make it look a little bit nicer to you. So if you like that, you're interested, the font is Cascadia code. It's in Visual Studio. You can just switch it and give it a whirl and see if you like the way it does things with some of these ligatures. Okay, so that's expression body members. And as you can see here with toString, it's the reason it's also yelling is because I'm only returning a string. So it really wants me to make it an expression body member, which I will, but I also want to change something here with the strings. So what I'm doing with returning toString is I have a multi-line statement. I want to return the name, ID, and age all on 3 different lines. And up until recently, the only way you could really do it is with a literal string, where you see this @ sign in front of the string. The problem is that the literal strings are not very white space friendly. You'll notice that I have the rest of the lines all the way to the left of the left gutter of Visual Studio. And personally, I think this looks ugly. I've never liked this. But you kind of have to do this with literal strings. So one thing you might also see people do is they'll put like all of it to the left. So at least it doesn't look too bad. But they're also not that flexible. If I wanted to have, for example, like a single double quote within my code, or if I wanted to have curly braces actually within the string, you start getting into escape hell, and it's not a very good place to be at times. So what C# did is in C#11 added this thing called raw string literals. So if I pick as a refactoring, I want to convert to raw string literal. Let me just do some quick formatting here. We'll do the expression body member. We'll move that over, and then we'll do that. Same thing. But what a raw string literal does is it says, by default, you have 3 double quotes at the beginning, at the end. Okay. But this end one is essentially defining where the basically beginning of your string line is for each of the lines within the string. So I could move these all over here like that. And this is going to be the beginning of that left gutter, so to speak. I personally like keeping them lined up this way, but either way is fine. So think of this if you're writing Markdown and you're using a code section and you do like 3 backticks, this is essentially the same thing. Yeah. But what's also nice about this is that it makes it pretty easy to do you never have to do any escaping in a raw string. For example, you'll see that raw strings can also be interpolated. So that's why I have the $sign in front of it. And that's why I can fill in these holes with values, just like I've always been able to do with interpolated strings. But what if I wanted to put in curly braces around the name for whatever reason, like this? Well, now I have a problem because it's trying to say this should be filled in with something name, and that's not the intent. So what I can do is say, well, a single curly brace is what I literally want to have in the string. So I do $sign. And now what I do is I come into here, and the way to fill in the holes is to put 2 curly braces in. Okay. But you'll notice that the name value right at the beginning here, now that's going to be a literal curly brace on either side in the string. So you don't have to do escaping anymore. You can just basically say, hey, that's, the double curly brace is what's actually going to be the place where the hole gets filled. You can also do this with quotes. So let's say for whatever reason, let me back this up because quite frankly, I don't want to have that in there. But let's say I wanted to have name start with 3 double quotes for whatever reason. Who knows? That's something you just want to have literally in your string. So I do that. And now you see I get a bunch of errors because it's thinking that's the end of the raw string literal. Well, the way to get around this is just add an extra double quote. And now you have 3 double quotes within my string, but that's literally what's going to be in the string. And if I wanted to have 4 double quotes in a row, what do you think I would do? You'd put 5 here. If I wanted 5, I would put 6. You'll always win with this approach. So raw strings are actually very, very flexible. And I've discovered that I really, really like them, especially when you do source code generation, which I'll talk about later on as well. But you can use these for anything in the strings. If you're trying to create JSON, you could just put JSON within a raw string, and it formats a lot nicer than what you'll do with like literal strings. Yeah. All right.
Jason.
Yeah.
Do you happen to know how that works differently on a PC versus a Mac, where new lines are CRLF versus just LF?
They should be targeting the target operating system that you're on.
So if you've got 2 people on your team and one person's on a PC and one person's on a Mac, will they fight?
Nope. Works just fine. You see over here on my left shoulder, that's like, this is my personal life here with my computers. That's my work life with Rocket over there. And on my team, we have people that are like me. I'm a Windows user because that's just what I'm familiar with. But we also have people that use Mac and they use Writer, and we use raw string literals everywhere in our code. Never been an issue, never been a problem. So, and it's a good question, but the thing to keep in mind again with C# and .NET is it's cross-platform. So those things should, without trying to do too much hand waving, should just work. The vast majority of things in .NET are meant to work no matter, the way you would expect it to, no matter what operating system you're running on. Yep. All right. So that is raw string literals. I'm going to go to describe age here. So I want to have this method that describes the age of the person. And I have not hit immortality yet, though I think Rocky's old enough to be immortal, but see if he's paying attention. But I have this big complicated if statement here, and I would venture to guess that you've probably run into something like this before with code that you've written as well, where you like say, if it's this, then I do this, else if it's this, whatever. And this works and it's fine, but it can also be, again, a little bit noisy. C# has been adding these things, or your Jason's age catches up with mine just a little bit, but it's kind of like asymptotically will never cross yours. You know, it's always going to be less. So I win. With C sharp, since version 7, it's been adding in these concepts of pattern matching. And there's property patterns, there's positional patterns, there's condition, there's all sorts of patterns that have been added now in C sharp. And one of them is this switch pattern. So if I take this code and I say, hey, help me out here, I want you to convert it to a switch expression. And what it will turn my code into is this. And again, because now it's one expression, should turn it into expression bodied member. And so I'll move that over. Nope. I like the arrow up there. I'm going to move that here, and then I'll just move that over by one. But all that code that I just showed you turns into this. You'll notice that now I also have and in the code. So this is almost feeling like the days of VB, and you don't have the double ampersands in there. So, but this just shows you that instead of having those big blocks of code, now I just have, if it's greater than or equal to 1 and it's less than 1, it's an infant, you know, greater or equal to 13 and less than 18, adolescent, so on. So this is, again, is just a small example of where you can use patterns in C sharp to make your code arguably very concise, and I think is actually more readable. Again, people may disagree, but I think this is easier to read. I think this is much better to maintain over time. And one thing to keep in mind is if I take off this last default one, you'll notice as the switch gets a red squiggle and it says the switch expression doesn't handle all possible values of its input. You won't get that from an if else if type of approach that I had before. It's telling you that, well, a age, which is an unsigned int in this case, what happens if you're over 110? If I do this, then it will say, aha, okay. That's going to say it. You're obviously handling now anything over 110 and beyond, and that person's immortal. But the point is, C sharp will tell you with the switch expression if you haven't handled all exhaustive cases, and that little underscore there is basically saying anything else. Do what's on the right side, which is to return that string immortal. Okay. So that's patterns in C sharp. The next one is parse and try parse. There's going to be a couple things that are going to kick in with this one. The first one is getting to this nullable annotations, nullable reference types in C sharp. And so you see that S has a squiggle and it's saying that I need to validate this parameter. And the reason why is because if I say string when I have nullable enabled in my code, I am saying I expect this to be not null. Nullable reference types and nullable annotations don't enforce this. That's why they use the word annotation a lot, because it's expressing my intent. It's expressing my expectation of what should be coming in. Before nullable reference types, you would just get a string, but you could pass in a null. And if you're not careful, that would cause this line of code to fail with a null reference exception. Now, with nullable reference types, well, I could still pass in null. But you'll notice that the compiler is smart enough to say, hey, you're using this and you haven't checked to see if this is null or not. So now what I can do is do a throw if null. And so you can consider that like a preconditional check. And now the compiler is smart enough to go, you made sure that's not null. And if it's null, I'll throw an argument null exception, which you still get an exception, but that's better than a null reference exception somewhere else in your method that you have no idea where it came from. And now I'm guaranteed that yes, this line of code won't fail with a null reference exception. Okay. And the same thing is happening down below here with try parse. So that's getting rid now of these null reference checks. And that's nice. That's really nice. But there's even more that you can do with nullable reference types, a lot more than I'm going to do, because again, in this presentation, it's not my intent to go through every single feature in detail. That'd be a whole course over weeks, you know. So this is just kind of to wet your whistle a little bit and see what's there in different versions. So There's other things you can do with nullable reference types. And I'm going to show that by kind of changing what I'm doing with parse and try parse here. You'll see that when I do a parse on uint, that's saying I should actually pass in this thing called a format provider, because on globalization, I may care about what is actually, like in some countries, they actually use a comma instead of a, or they use like they use the comma instead of a dot where we would, and vice versa. Or, they do different notations for a value that are different than what we typically see in America. So you have to be conscious of that, especially if you're writing code that's meant to execute for different cultures. So what I want to do is say, I want to take in a string that is split on a comma, and then I'll just parse the GUID with the first part, the name as the second, and then the third is the age. Okay. But that may be formatted a little bit differently. The real thing here is I'm using what's called this parse pattern, which we've had in .NET since 1.0. If you notice, if I ever wanted to parse an int or a GUID or anything else, they all kind of followed this convention of saying dot parse. You pass in a string and it will return you back an instance of whatever the thing is that you want to parse. But if it didn't work, it would fail with an exception. Okay. And then in 2.0, they started pushing this try parse pattern, which is to say, don't throw an exception because that can be a little costly. Tell me if that actually worked or not, if the try parse was actually good or not. And then I'll pass in the out parameter here, the result, if it was good. Now, if it's bad, it's going to return null here. But you'll notice that this is one of these cases where this out parameter may or may not be null, depending upon what the return value is here. But the other thing with parse and try parse and so many other things that we do with static methods is there's never been a way to enforce a pattern this way, like what we do with interfaces. If we want to have a type do something the same way, we can create an interface, have that type implement that interface, and then we know because of the signature that's there, that type will implement it correctly. Well, that's changed now because of in C#11, there are these things called static abstract members and interfaces. So give me a second here because I need to do a little bit of magic here. iParsable of person, okay? And now I'm going to say implement it, which will give me two new versions of parse and try parse. And I'll explain all this in just a moment because I need to kind of move code up here. And then I want to take this implementation and pull that out. No, wait, I did that a little bit wrong. There we go. Let's grab that, put that there, except we need the blocks. There we go. And then the try parse, now that we have parse done that way, the try parse, we're going to grab, actually, we'll grab all this and notice that we have that result, which is null, except now what we're going to do is we're going to get rid of that and we'll put that there. And then we'll get rid of our current try parse. Yay. So what just happened? Let me move some of this stuff around a little bit to make it a little bit easier to see. What happened is with iParsable is I have this interface that if I go to its definition, go to definition. Why are you not going to definition? Oh, it's not being very friendly right now. It doesn't want me to go to definition. But if you went to the definition of iParsable, what you would see is it has two methods that are defined like this. They're static, which is weird. For so many years, interfaces just defined instance level members. But now we can actually define static level members. So we can say on this type that it's going to follow this parse and try parse pattern where it also is taking in a format provider, which is what you should be doing. And now I can just pass that provider in here. That all works. And you'll also notice that try parse has a couple of attributes on it that are based for this nullable reference type analysis. You'll notice that with person, the out parameter, that it says maybe null when false. So what this attribute tells the compiler is this parameter might be null if you return false, which is true. if the parse didn't work, we're going to return a null. But if it returned a true, then we're saying, yes, it will have a non-null value. So this is a way to do an annotation to say it could be one or the other. And there are other attributes you can use for nullable annotations as well. But again, you can see here with parse and try parse, now I'm doing it, quote unquote, the right way, the way that these two methods should actually be implemented. But wait, there's more, because I also have a way on this class to add two people together. Now, so the way I'm doing it is kind of weird. I'm actually saying, well, I'm going to return this person with a whole new identifier. I'm going to combine the two names of the people, and I'm going to just set their age to 0. Like somebody's newborn, it's taking both names and combining them into one, something like that. But being able to implement an operator on a type is something we've been able to do since day one. But now with static abstract members, what I can do is say I addition operators, a person, person, person. And you'll notice I don't get a squiggle, because on I addition operators, now it will go to definition. I don't know what it didn't like about iParsable. It doesn't like going to definition on that one, but it will for this one. Whatever, Visual Studio, not my fault. So you can see with this one that it defines two operators on the interface as static members. And so I can do a checked addition or just an addition. And as you can imagine, with all the types, there's addition operators, identity operators, subtraction operators, all of these interfaces that define these operators, you can use to say, if I want my type to support the addition operator, you should actually use this interface and do it that way, because then you'll be doing it the right way. It just so happened that I had the operator on there already, so it already realized that when I wanted to implement the interface, I was already doing it correctly. And then we'll just make this an expression body member, and off we go. Okay, but actually I can't do that, because again, I need to have the nullable checks in here, which I don't have just yet. So I'm going to just put in A and B. Now the code is good. Okay. One other thing that you can do when you create a new type like this is, if you want, it's not giving me the option here right now, but if you want, if sometimes you'll see, depending upon where it's in the code, I don't know why it goes away when I put in these two things here. If I take out those checks and I make it an expression body member, you might see there's there's smudge here again. Okay. And what's saying is new expression can be simplified. So let me actually back this out. And what that is telling you is saying you can actually create a new object like this. So I can take the type off of the constructor, and if the compiler can figure it out, because I'm returning a new something, well, what would I be returning? In this case, it's a person. So it'll say, you're trying to create a new person. So I don't have to put the name of the type there if I don't want to. Okay. This I have a little bit of hesitation around, because in some cases it's actually very helpful. If I don't have one in this type, but if you have a field that's read only in your type, if you ever have like a dictionary of string and person or whatever as a read-only field on a type, but you want to make sure it's initialized, you don't have to say now like private dictionary of string, person, stuff is equal to a new dictionary. You don't have to type all that. You can actually now just say new. Okay. And actually, there's a better thing you can do. I'll show you that later. You can see the squiggle there. It's trying to give you another thing you can try. But the point is, with target type new, that's the feature that that's called, is you don't have to specify the type when you create it if the compiler can figure out what that type should be. This is helpful, but can get really confusing if you start nesting them. Like I could say, instead of gwid.newgwid, I could say new here. And that would give me an empty gwid, which you probably don't want. But the point is it knows that I want to make a new GUID here. I find this to start getting to be pretty unreadable. So one level deep is, I think, about as far as you want to go with that. That's just my personal opinion, but it can be a useful feature. Just don't overdo it is my suggestion. Another thing with properties down here, a new feature that you can use with properties is what's called emitters and required. So right now my type is mutable. I can change the state of the type, change its age, the ID, and so on. A lot of times, and by default, I really like designing types that are immutable, not just for concurrency reasons, because if I make a type immutable, I can make an instance of that type and pass it into a method. And if it does something with tasks and has multiple tasks using that type, and if we try to change it, it can't. And then I don't have to worry about concurrency or race conditions or anything like that. I don't have to worry about anybody being able to change that instance of that type. So immutability is good. And so what you can do is you can change your properties from being mutable like this to being immutable, but also support an object initializer syntax. The way to do that is to use init. And so now what this says is this property can change in you can set it in an object initializer or a constructor, but once an object is set, you can't change it anymore. Okay. You can also state that these properties can be required. Okay. And so now it's saying is these have to be set by the time the constructor is done or once an object is initialized. So now you start seeing that there's some squiggles around new here and new person here, because what the compiler can't do is notice that even though I'm calling this constructor, looking at it from the outside, it doesn't know what the constructor does, even though we know as the designer of this type that I am setting all those properties to the right values. So you can do one extra thing here and say sets required members. And now that goes away. Okay, so if you want to use required, just keep in mind that if you run into some compiler errors, you might need to put that attribute on your constructor just to inform the compiler that, yes, you are setting these. Don't worry, I've got that handled. Okay. One of the last things I'm going to show with this code, and then I'll move on to a couple more things before I wrap it up, is there's actually a new type, even though it's kind of syntactic sugar over a class or a struct. And this new type is called a record. Okay, bless you. So records are also, they're really nice short syntax if I want to just create a type that's immutable, that's equatable, that's deconstructible, and so on. Okay. And you might wonder what deconstruct is. So I'll show you what that is in just a moment. But if I wanted to do all that by hand, that's a lot of work that I have to do. Yeah. What I can do, and I'll show this with the person type in just a moment, but let's just say I had a public sealed record customer, and that customer has a name and they also have an ID. That's it. This one record, which is a class by default, you can make records structs if you want. The struct actually has to go here. What's it telling me now? Oh, and then if it's a struct, you don't seal it. Okay. But that can be a struct. It can also be a record if you want, or a class if you want it to be. But this customer type implements equality. It has all these things here as properties, as immutable properties. And so these record types are really nice for if I want to just pass these data values around. You can do that in literally one line of code. You can also do it if you want for like classes. You'll notice I have refactoring here to convert this to a positional record. And so there's a lot of changes that are going to happen here. But if I accept that, it doesn't do it quite correctly. The refactoring is a little off, and that's why I keep this ending point thing here, because I just want to grab all this and put this in here so that I know I have the right thing. Okay. So now this is a record, but just because it's a record, I can still add on things that I want. Like I want it to be parsable. I want to be able to add these persons to add people together, and I also want to override toString, and I want to still, so you can still add things to your records if you want, but you'll notice that my properties are gone. I don't have them there anymore because a record will define them for me. Okay. So records are a recent addition as well, and that may be something you want to take a look at. Okay. Now, let me go through a couple of instances of where I would want to like use some of these types and use them like in console apps and also in tests to illustrate just a couple more features that you can use now in C#. So one of them is with source generators. So I've got my person type here, and let's say that I have some service that when I call get on it, it's going to call back to this repository that I'm injecting on the constructor, the whole dependency injection thing. And I'm going to actually call retrieve on that. Now, if I want to write a test around this, one thing you could just call something that actually implements this and pass it in, but that may be a little bit heavyweight for the unit test that you want to write. And so you could use a mock. Okay? And you may be familiar with libraries like MOQ or NSubstitute or Fake It Easy that allow you to write mocks for tests. What I decided to do is actually write a library called Rocks. And what Rocks is a mocking library, but uses this thing called source generators. So in C#9, they added this feature called source generators, which, no, I did not name it after you, Rocky, but it's actually Roslyn plus mocks. And so I combined those two together to get rocks. So what a source generator does is it says, I can look at code that exists in a project and I can generate code based on the code that exists. I can't change it, but I can build new code. And you'll see source generators now in a lot of places in C#. You can use it to implement regular expressions. You can use it for JSON serialization. Another one is actually for p-invokes. It does some source generation to make that easier. There's a lot of places now within .NET where they actually use this feature to build code at compile time, not runtime. This has a lot of benefits for speed, for performance. It's actually better for ahead of time compilation and other things like that. So what I did with this Rocks library is I said, I want to basically create the ability to mock this type. That's what this attribute does down here. And so now what I want to do is when I'm going to test my person service to say, when I call get, I should get a person back. I'm expecting it to exist. And so this type here is actually created by my source generator. And then I can say, I expect the method retrieve with this ID to return a value of this person up here. I create an instance of my mock. I pass it into my person service here. I call get on the service, which in turn is going to call retrieve. It will return this person. And then I can assert that I actually got that same person back and that all of my expectations actually happen. That's what verify does here. I can also do it where I don't return something back. I return a null, and I can check for that as well. And if all's good and I run my tests, you can see down at the bottom here, 2 tests pass. I can show that up here. Okay. Now this code, you don't have to take a look at. If you want to, you can have 12 into it and you can see all the horrors that lie underneath the scenes. This is what Rocks does for you, okay? But you don't have to care about what a source generator does. You just want it to work the way that it's documented to work. Okay. So you really are just looking at this. Okay. But again, all of this is compile time assets. And so you don't have to do any runtime reflection, late bound stuff that may or may not work depending upon what the library does. So source generators is a very powerful feature. It's not easy to write them, but if you do spend the time on them, Rocky's here. We've had conversations about stuff he can use in CSLA potentially to speed things up. And you can start getting the gears turned and you start going, this could be actually very beneficial based on what my library does to make things faster. I've actually written a prototype CSLA serializer to replace the default serializer in CSLA with a source generated one. And it makes it, I think, at least 3 or 4 times faster and consume about, I think, 25% less code and never go beyond Gen 0 in the garbage collector. Just because I do it at compile time and does the same exact thing. So they're really, that's a really cool feature in modern C# code that you can use. The last thing I want to show you is if I go to a console app where I'm using this person, and I'm just printing that person out, you can see that I can add 2 people together. I can have an add method here that all I care about is whatever I pass in for the type of T, that it's constrained to do addition operators. I don't care what it is. It can be ints, it could be GUIDs, it could be a person, doesn't matter. I'm just going to add them together with how it implements an operator plus. And so when I run this, you'll see that I do Control F5 here and I zoom in a little bit and I say adding 2 people together, you'll notice that the age becomes 0. I get the first names combined and it just works. So that's also something that's really cool about static abstract members is you can make what they call almost generic math. You can make operators generic and you can create methods that are generic on those operators. And that's really, in my opinion, that's really, really cool. That's very powerful. You'll also, one last thing I'm going to show you here is collection expressions. I mentioned that when I was creating that dictionary that it said like there was a new and you didn't have to put in the name of the, like say dictionary string of GUID. Well, you can actually go one step further now in C#. You'll see here that when I call average, which is just a method that I have here that takes a bunch of people and gets the average of all their ages, that I'm creating a array to do that. Well, what you can use is this new thing called collection expressions to basically do that. And so what collection expressions do is basically puts it with that array syntax, but it doesn't mean it's an array. What this is saying is this is a collection of things and I'll figure out what that type should be based on the target. And so in this case, it's an IEnumerable. So what would that actually do? The response from the C# designers is the right thing. More to the point, it's saying you don't care. It's going to basically do the fastest thing it can. Maybe it'll allocate an array underneath the scenes. Maybe it will do something else, but all you know is that it's going to produce something that's an IEnumerable so that I can call this and then get the average of it. The nice thing about this syntax is that if I actually wanted to change it to something like, let's say I made it a person array here, this code didn't have to change. If I made it a list of persons, not service, persons, that doesn't change either. It's smart enough to know what the target is and adjust accordingly. So this syntax I really like too. Again, it's a small thing, but it's a very, very flexible feature that you can use within C# for collections. One last thing that got added into C# 13, I wanted to at least mention C# 13, is one of the features that they added around passing in like 0 or many values is params. Well, params has been around since 1.0, but you couldn't just use any arbitrary collection type with params. That's changed now in C# 13. I can now define a function to have params of a read-only span, for example, and that will work. Now, it doesn't work with my implementation because there is no average method for a read-only span. But you can use any collection type essentially now for a params type. And this actually has an advantage in terms of speed and allocation. Spans are very efficient. And so you can actually get some gains if you're using params in C# 13 to start using other types than what you typically had to do in the past. Yep. Any questions on anything I've done in the demo before I go back to my slides?
Nothing here in the room so
Okay.
far?
All right, cool. All right. I'll go back to my slide deck then. So again, just to cover real quickly, I went through some features that you can use that aren't in C# itself, the things I would highly recommend you use for managing solutions and projects for in Visual Studio for the code that you're writing in terms of editor config and those directory files. And then these are the features that I covered in my demo. As you saw with the numbers that I was showing before, there's a lot more features in C# than this. But again, it's not necessarily about learning all of them. It's just some of them will be more applicable than others. And I'm actually going to come back to that in a moment. So what to take away from all this? The first thing is, where are we going to go from here? I don't see anything changing. I really don't, in some ways you think, when is a language finished? Does a language ever just stop adding features? And like they just say, this is done. We don't need to do anything to this anymore. If a language stays somewhat popular and used by many people, I think that evolution just continues with the pace in C#. I think we're going to stay on this yearly cadence every year of getting a new runtime and a new version of C#. So that's not going to change. With C# and .NET being open source, knowing that roadmap of where the path is going in the future is actually not as much of a mystery anymore. In fact, all of the design work, or virtually all of it, unless Microsoft is doing a meeting internally, all of this is done out in the open. So you can see, like with C# 13, all the things that they were looking at adding for the latest version of C# and any version in the past. Like all the notes and the language design meetings that they have, they take notes on that stuff and put that out there. You can see what they call the working set. So these are the things that they're thinking about for the next version of C#. It doesn't mean that these are actually going to be in there. It just means that it might be in there. You see in the middle this thing called field, keyword, and properties. This is something that they've actually toyed with for the past couple of versions, but they took it out of C# 12. They put it into C# 13 as an experimental feature, but it's still not supported yet. So it looks like they will probably add it as a supported feature in C# 14. But this working set is not a guarantee of these will be in the next version. These are just things that we're looking at that may be there. Okay. And again, if you look at my slide deck and in the notes section, you'll see the URLs where you can find out this information. So there's still going to be things coming in the future. Some of these features may actually be pretty big, like extensions. That's been something that they've talked about, I think, for almost a decade. And they were thinking of putting that in as an experimental feature. C# 13 didn't make it. So they're still hammering out the details on this issue or this feature. And hopefully they'll finally have something available in the near future. I think that the thing that is very clear is that there's no let up in terms of the amount of study that we need to do. There's always going to be new features. There's always going to be stuff that's there. But don't get overwhelmed by that, because we have tools like you saw with all those refactorings that I was doing with all those little hints, squiggles, smudges, and everything in Visual Studio that's trying to help you to say, maybe there's something, if it's not an error, maybe there's something here that you might want to change your code style to, because that may help you get maybe a little bit more concise, or maybe make things easier, more flexible in the future. But there are other features like these that are in C# that, I'll be honest, I don't see myself ever using, and I would venture to guess most, if not all, not all, but most C# developers will never use. Like a method level async method builder. That's something you can do. Who would do this? Very, very few people. Function pointers. You can actually get a function pointer. You can get a pointer to a function in C# now using a very weird syntax, but you can do it. This is something that the vast majority of C# developers will never need or use, but they're there for very specific and useful cases. The language designers of C# don't just put in features because they feel like it's a cool thing. There's very deliberate action that's made to put in a feature in C# because there's a lot of cost involved in designing it and developing it and maintaining it in the future. So sometimes if you think, why doesn't C# have this? I think this would be really cool. They should just add this in there. Well, yes, but the process to go through that to make sure this is something that would be useful, however you define that, such that it should be in the language proper is not an easy decision to make. Okay. But there are features that, okay, they're there. Maybe you'd run into them, but you probably won't. So it's a balance. You see that number of all the features that are in C#. Some of them you're going to use on a day-by-day basis. Some of them maybe once in a while. Some of them you may never use, and that's okay. I think don't feel overwhelmed as this pace continues that you have to know the ins and outs of every single language feature. The tools can help. Some of these are common, some of them are very, very rare. And so always kind of do that check of, is this something that I will use, and maybe this is something that it just doesn't pertain to me, and that's okay. Okay. So hopefully you got something out of this. Hopefully there's a couple of things that you picked up on that maybe you didn't know before. And if so, that's great. I don't have anything to do tonight. So if people want to stick around and ask questions or talk, that's fine too. But in terms of the presentation, I am done. So I am basically going to say for now, I'm finished. So thank you for having me. I appreciate it.
Any questions?
I know we said throughout this presentation very early on that there was generally no, and at the end, we also hinted that the abstractions may be more beneficial because the underlying data structures would be picked better, but I was just reading some point in the last week or so that they were like, the .NET team is still working out why numerable wasn't running as fast as the fuller statement. Or any of the new features in C# with the abstractions less efficient, and would that ever even have any type of measurable impact ever on a code base, especially if you were doing things like financial data or tax data, huge sections of things you need things to run very fast.
Lee, could you repeat that? Because I kind of caught bits and pieces of it. I'm sorry.
Yeah, I mean, I can give a short version of it. The short version was, have there been any enhancements recently that actually make performance worse? But that's a very summarized version. You want to come over to the mic?
I just mentioned that I knew that the compiler team was still dealing with the reality that a for with an an int operator is faster than a for each on an enumerable, and they were trying to work that out in the new versions of C#. And very early on in your presentation, you mentioned that the things you were showing the abstractions were not going to impact performance. Later on, you also hinted that at the very end of your presentation that the underlying selections would even maybe be better. I was wondering if there was any new features in C# that you knew of that would actually impact performance, especially on very large data sets. Thank you.
Okay. Generally, and I don't mean my answer to sound snide at all. It's going to potentially sound that way, but that's not my intention. The C# designers are not going to put something in to make your code perform worse. They're really, 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 really going to try hard to make sure that any feature, anything that they add should not degrade performance with the way that it's done. Now, with what I'm showing here in my code, this collection expression, and let me go back to making this an IEnumerable person. And this is one of the things that they talk about with this feature is, again, IEnumerable is an interface, but what I want to pass in is something that is IEnumerable. So it has to be something concrete. And what is that? And what they said is they basically have to come up with some heuristic, some way to say what is the best thing to pass in here in terms of memory allocation, in terms of performance, all these things. Now, I don't know actually off the top of my head, would they make this an array? Would they make this a list? I'm not sure. Would they make it something else that is neither one of those that you don't really care about? You just know that you're passing in a collection of two things that's enumerable. But again, the reason that you use a collection expressions is you're basically telling and letting the compiler make that decision for you. Now, if you had large data sets, it basically with this specific feature with collection expressions is it should be no different than if you wrote it by hand. If I passed in like a list, if I made this like the way I had it before, which is like a new list of persons, and then I had Jane, I think I actually had it as an array before, and I did that, it should be no worse than that, or it should be better if I use a collection expression. Okay, so as far as I know, there's nothing that they're very, very conscious, and the .NET team as a whole is extremely conscious of performance with what they build, either in the language or with any of the APIs that they create. There's an article that's written every year by one of their, I think he's a principal or distinguished engineer at this point. His name is Stephen Taub. And it's called like performance improvements in .NET, and then whatever the new features coming out. So he's been doing this since like .NET Core 2.1, I believe. And each time the document is like, if you print it out, he basically says, don't print it out because it's literally going to be hundreds of pages long. I would highly recommend reading those because it shows just how much time they spend on and continually finding new ways and new things to do with the compiler, with the jitter, with head time compilation, with just APIs in general, all this stuff to make things just that much more faster with every new release. With the compiler, it's the same thing, so I am not aware of anything, and I'm not saying it doesn't exist, but I'm not aware of anything in C# that is a feature that would actually make your code degrade. But that may be just something I am not aware of. So hopefully that answers it.
We're just about out of time before we have to leave the space. Any last questions? No? Awesome. Thanks again, Jason. Really appreciate you presenting tonight. That was fantastic.
All right. See ya.
Have a great night.